Cost-effective smart real-time automobile monitoring and security system. Abstract transportation has become major part of human life. This paper aims at designing an implementation of automobile monitoring and tracking system based on ARM7 that aims at addressing real-time transportation issues such as the vehicle theft and road accidents developed through modern technologies such as IoT, Internet of Things. This project could not only be easily deployed for the existing automobile but also be further modified in future as per the needs of the user. Also, the proposed system uses universal asynchronous transmitter-receiver-based devices such as GPS, ESP8266 Wi-Fi and HC05 Bluetooth module for tracking, sending, and receiving data to the cloud server respectively, monitoring the current location of the system from remote station. Furthermore, application-specific sensors have also been added for providing further assistance to the driver such as ADXL335 sensor, IR sensor, and Mq7 Gas Sensor. Keywords: ARM7 IoT ESP8266 HC05 UART GPS Wi-Fi Bluetooth GPS Cloud Server MEMS IR Sensor Mq7. Introduction. Transportation plays an important role in development of a country and its economy. With the improvement in the infrastructure of the metropolitan cities, transportation becomes even more important to serve various purposes such as supply of raw materials, from faraway places, connecting cities for labors and other purposes. This leads to increase in the automobile population across these cities to prevent time lapses or delay for supply of raw materials or jobs. But increasing in the automobile population there has led to sharp increase in problems related to the automobile such as road accidents and cargo vehicle theft that becomes difficult to solve on micro-level basis as it's difficult for the driver to track and monitor the automobile at all instants. Given rise especially where the automobile population increases on daily basis in A. Anisha et al. Thus continuous or real-time automobile tracking and monitoring becomes necessary such situations in order to prevention of mishaps which would lead to the loss of precious raw material or even human life as described by Saurabh H. Chakol et al. 2. Thus the proposed system aims at addressing these problems in a less circuitous and economical manner. The project aims to rectify the drawbacks in previous existing systems such as Chennakeshvagovdavi.R et al. 5. Bulky circuitry, use of embedded C language for reducing the overall bulky code size for future addition and modification based on the user needs. Taking all these setbacks into account, this system has developed. The entire system is implemented using ARM7 controller board using embedded C programming in Keel software. UART devices have been used for tracking and automobile monitoring through GPS and DRAC Ramachandra. Department of Electronics and Communication Engineering. NIT Meenakshi Institute of Technology. Bengaluru, India. Wi-Fi module. The entire system is attached inside the vehicle which needs to be tracked and monitored. As soon as the system is switched on, the GPS antenna is connected to the satellite and tracks the current location of the vehicle. This data is then transferred to the cloud server via ESP8266 module. As soon as the cloud server gets tracked data from the cloud Wi-Fi module, an alert message is sent to the registered number and the remote monitoring system that is connected to the cloud. This alert message sent contains the current location of the system that could be dynamically tracked and monitored. Safety of the system is demonstrated through Bluetooth module and electronics lock system. This Bluetooth module and electronic lock system works based on user's specific voice command. Based on the voice command, this electronic lock opens the system. Also, application-specific sensors has been deployed alongside tracking and security to automobile for providing ease to driver extensively under different circumstances. Whenever there is change in parameter observed by the system, it automatically alerts the user and stops the motor vehicle. The system is demonstrated through a DC motor. This system could be extensively helpful for motor-based vehicles where tracked and monitoring becomes necessary, such as cargo trucks, cabs, school buses, vans etc., as the system could be easily be deployed in the motor-based. Figure 1, Automobile Tracking System. 2. Existing works and drawbacks. Study of previously existing implemented system reveals that most of the works have concentrated on automobile tracking that are designed using GPS, GSM devices, and SSIM 900A. For instance, Anisha et al. Author proposes GSM-based tracking system. Service in this system includes GPS tracking the location of the user and GSM sending the location of the user to the registered SIM card. All these data is being stored in the central database. User is able to retrieve these data as per requirements by sending SMS through wireless GSM network. Similarly, Sarab.H. Chakol et al. And N.Dirthi et al. 2 GSM-based tracking system is being incorporated for the in-vehicle system. This system also involves a dedicated server that could retrieve the required data by sending a request message. While Chunlong Ma et al. 6 the automobile tracking is implemented through Linux-based embedded microprocessor where cameras are the part of system in addition to the basic tracking using GPS and GSM for taking picture during emergency situations. The structure of GSM Gprs-based tracking system is shown in the below figure. Figure 2, Structure of existing automobile tracking and positioning system. But the above proposed researches lack similar works for enhancing the security of the automobile, which is important for transportation of precision's raw materials. The driver safety is also not being concentrated in these works. The usage of GSM module for data transfer in places with weak or no GSM network would cause difficulty in the transfer of data from system to server or vice versa. Even though the GSM module covers a wider range, WAN, compared to its counterparts such as Zigbee, has much shorter range, is quite expensive in real time. Usage of GSM module increases the overall circuitry of the system such as Sulochana et al. 11. 3. Proposed scheme. The proposed scheme not only aims at eliminating all the drawbacks and errors in existing research works as discussed above, but also to add on additional features to improve its significance. The below figure shows the block diagram of proposed system. The block diagram could be categorized into 4 sections based on the function, I, tracking, 2, security, 3, application-specific sensors, 4, controller. Figure 3, shows the block diagram of proposed system. A. Tracking. As defined above, this section contains blocks for tracking the automobile. This includes GPS antenna, Wi-Fi module, and others. 1. GPS antenna. The main purpose of GPS antenna is to navigate the current location of the automobile that needs to be tracked and transferred by the controller. GPS module used in this system is GPS 634R. The main advantage of GPS 634R has up to 51 channels for the acquisition engine and total of 14 channels to track the engine. It's able to receive signals from up to 65 satellites around the globe, thus providing precise location to its user. Later these data could be transferred into precise position and timing information which is read through UART or RS-232 serial ports. GPS 634R also has less power consumption and smaller size, thus could easily be accommodated any type of motor vehicle. 2. Wi-Fi module. The main function Wi-Fi module is to transfer of sensor data to the cloud storage through wireless network. This system uses ESP8286, which is a UART device that could be easily accommodated to different microcontrollers or act as controller, node MCU, based on requirements. First, the Wi-Fi module looks for different access points and then connects to a network for which the SSID and password is already stated in the program. Then the sensor datas are sent to the Amazon cloud server, from where this data are directed to the registered mobile number or remote PC. We visualize the current location of automobile. In this system it communicates with the main controller through serial communication. ESP8266 uses ET command for its connection to wireless network. Here the wireless network refers to user's mobile data which is pre-programmed for transferring sensor data. Figure 4 shows ESP8266 used in system. 3. Cloud server. The function of cloud server is to receive the location information from Wi-Fi and transfer it to the monitoring center. This system uses AWS, Amazon Web Service, for cloud computing due to its significant features such end-to-end encryption, economical, amount is charged only for data storage, better performance and reliability over other cloud servers. B. Security. This section aims at improving the security of automobile lacking in previously implemented works. This section includes Bluetooth module and electromagnetic lock. 1. Bluetooth module. The main advantage of using HC05 module is encryption and secured data transfer that could not be tapped easily. This project uses Bluetooth module for wireless communication between the system and user's mobile. In this system, Bluetooth is a part of security setup where the user is required to connect the mobile device with the Bluetooth module. This project uses HC05 Bluetooth module due to its low cost and less power consumption. This module could respond up to the range of 10 meters very effectively, thus making the system more reliable and secured. Figure 5. HC05 Bluetooth used in this system. 2. Electromagnetic lock. Purpose of electromagnetic lock/solenoid is to demonstrate anti-theft automobile system based on voice command. For this, electromagnetic lock with 12V supply is being used. This lock consists of 2 wires, red for supply and black for ground. Whenever the electromagnetic lock is on, the toggle is pulled back. I.e., automobile is open. When the lock is off, the toggle comes back to its original position, i.e., automobile is locked. Since the supply of electromagnetic lock is 12V, it can't be connected to the controller directly. Hence a relay is being connected as in between electromagnetic lock and controller. This project the controller sends signal to electromagnetic lock for opening and closing, which controls the brake of the motor vehicle. See application specific sensors. In addition to tracking and security, set of application-specific sensors have been included by the system for providing further assistance to user based on the sensor's applications. This includes IR sensor module, 2. Mq7 gas sensor and 3. ADXL335 accelerometer sensor. 1. IR sensor module. This system uses general-purpose low-power IR sensor module for demonstrating. The main purpose of IR sensor in smart vehicle systems is to detect and navigate the vehicle from imminent dangers of surrounding environment while transporting raw materials. This sensor operates on 5V and range of 15 cm detection. This module has 3 pins, 1 to supply, i.e. 5V, another to the ground and third to the input of ARM controller. This module could be programmed as per user's convenience. 2. Mq7 Gas Sensor. Mq7 is gas sensor that increases output voltage with the increase in concentration of gas. This sensor is highly sensitive to LPG and methane gas, which having low sensitivity towards smoke or alcohol. The system uses low-powered Mq7 gas sensor for detecting the consumption of alcohol. The sensor requires 2.5V for operation. The sensor has 4 pins supply, ground, and 2 digital pins. Based on requirements, user could adjust the of the sensors. Sensitivity. Figure 7, Mq7 gas sensor used in the system. 3. ADXL335 sensor. ADXL335 is a 3-axis sensor that detects acceleration of an object in the form of analog input. The system uses accelerometer sensor for detecting change in position and alerting. It consists total of 6 pins. This includes 3 analog output pins, 2 supplies, and a self-test pin where we check the functioning of the sensor. Here we check the change in the position of the automobile in each axis. If detected, alert message is sent. D. Controller. This section governs the flow of control between various blocks of the system. ARM7, LPC2148, has been chosen as controller over other microcontrollers for this system due to its diverse features such as low power consumption, 3.3V, smaller size, relatively cheaper, and most importantly its compatibility with the IoT-based devices. ARM7 controllers has wide range of applications in various fields such as development of medical equipments, transportation, agriculture, space, and military applications. Keel software is being used for programming, including initialization and displaying of various modules and sensors within the system and set parameters to various sensors for its coordinated operation and response. The controller. Embedded C is used for programming in Keel. The code is dumped into the microcontroller through Flash Magic serially. For system implementation and working. The system implementation could be classified into flow of hardware and software development. 1. Hardware development. The system deploys variety of hardware modules and sensors for various purposes as discussed in the above section. This section aims at explanation of coordinate working of these hardware devices with the controller for producing desired results. As power supply is given to the microcontroller, the system initializes, setting the initial values of the sensor to 0. The user is required to unlock before accessing automobile. For this it's required to pair the smartphone Bluetooth with the Bluetooth device of the system, say a specific voice command for the system to recognize. If the voice command matches with the command set in the system, the user gains access to the automobile, otherwise system is locked. Once this step is completed successfully, the GPS antenna senses the location at which the automobile is unlocked and sends message to registered mobile number / remote PC that contains link of Google Map location and text showing date and time of access through user's mobile data. As this step is finished, the controller continuously checks for any parameter from the sensor modules. The Mq7 Gas Sensor's output voltage is continuously monitored by the controller with change in concentration of gases in air. If the concentration of alcohol in air is above 0.05% or above 30 mg, the output analog voltage of Mq7 sensor increases. The user is alerted with buzzer. LCD display shows alcohol detected, after sending alert message. Similarly, a DXL335 sensor is deployed by the system for checking physical or positional change or tilt by the controller. If any change in position detected, the controller waits for the few seconds for the sensor to come to normal position. If sensor does not come to normal position even after few seconds, the controller sends alert message to remote monitoring center that contains link of Google Map where the position change has occurred. Figure 10 shows working of Bluetooth module HC05 in the system. As shown in the above block diagram, this system uses particular voice command through Bluetooth communication for opening of electromagnetic lock. For this, Arduino voice control mobile application is being used. For example, if open command known only by the system and its registered user is set on mic of voice control app after connecting it with the system's HC05 module, the electromagnetic lock opens and LCD displays lock open. The below figure shows Arduino voice control app. Here the mobile app acts as interface between Bluetooth module and the user. 2. Flow of software development. The flow of software development could be divided into programming various modules and sensors using embedded C and designing user interface showing dynamic location. Programs are written, tested and debugged and dumped into controller through Flash Magic. The design of user interface that sends dynamic location of the user to remote monitoring center through Eclipse software using JavaScript in the back and an HTML for displaying the user interface panel. System algorithm. Step 1, start. Step 2, system initialization. Step 3, connecting user mobile data with system's Wi-Fi module. Step 4, opening of electromagnetic lock through voice command. Step 5, vehicle started, alert message is sent to registered mobile number. Step 6, controller checks for parameters in Mq7 and IR sensor. Step 7, if detected, user is alerted with buzzer and LCD display. Step 8, check for any change in the position of the accelerometer sensor. Step 9, if detected for long time period accident, alert message to registered user's mobile. Step 10, stop. 6. Flow chart. 7. Experimental results and observations. The above figure shows the hardware setup of implement system. The controller is powered through 12V lead acid battery for demonstrating the working of the system. The above figure shows LCD display output. Here the LCD display's lock is open along with the voltage in lead acid battery. Figure 15, Opening and Closing of Electromagnetic Locks Toggle. The above figure shows opening and closing of electromagnetic locks toggle implemented through voice command and HC05 Bluetooth module. The above figure shows vehicle accident alert message received to registered mobile number. The above message also contains link of location the motor vehicle. The above message is received to registered mobile number when the position ADXL335 accelerometer sensor position is changed from its normal position for prolonged period of time. The above figure shows GUI output window that displays latitude and longitude of the motor vehicles. The above figure shows dynamic location of the automobile on Google Map along with latitude and longitude viewed through the SMS link. Figure 20, Mq7 Sensor Output. The above figure shows LCD display output of Mq7 Gas Sensor along with lead-acid battery voltage. The maximum concentration of alcohol allowed 0.05%. The sensitivity of the sensor could be further increased as per requirements. The below table shows the experimental outputs each sensors and the system's response to each of these outputs. The outputs are taken for application-specific sensors. Table I shows experimental outputs of each sensor along with the system's response. 6. Conclusion and future works. This paper presents a novel and sophisticated method for automobile tracking and monitoring in real time through IoT, Internet of Things. This system could be easily incorporated into motor vehicles at lower cost in major cities of India such as Bangalore, Delhi, and Chennai, where vehicle theft and road accidents are one of the major problems. Also, application-specific sensors have been incorporated to the system that could be useful for real-time situations. Further modifications could be done for improving the application's effectiveness of the system, such as fuel level monitoring system within by extension within system. Also, the system could be further be secured by the addition of antenna tampering alert that identify and alerts the main office whenever there is attempt to break GPS antenna within the system, thus improving the system's overall reliability.